Okay, so let's do one more example where I'm starting with the equation not only not in standard form, but I'm going to need to complete the square twice here. So I'm going to rearrange and put the x things together and the y things together and the constant on the other side of the equals. And you need to be really careful when you're factoring out with minuses. So I have 2 times x squared plus 2x. Then I'm going to factor out the minus, and that will give me y squared minus 4y because I'm factoring out negative. So then let's see what we need to put inside the parentheses to complete the square. So I take the 2, cut it in half, that's 1, square that, and add that much. But then notice that you've actually added 2 because you have a multiplier of 2 in the front. Then I have minus, and I have y squared minus 4y. I take the negative 4, cut it in half, negative 2, square that, and I get positive 4. But now notice that I've actually subtracted 4. So I need to do the same thing on the other side. Okay, so now I have 2 times x plus 1 quantity squared minus y minus 2 quantity squared equals 2. And I need to divide both sides by 2 so that I'm in the standard form. So I'm going to have x plus 1 quantity squared minus y minus 2 quantity squared over 2 equals 1. So that's the first part of write it in the standard form. And then let's see what we can figure out. The center I can read off from the equation is negative 1 comma 2. So I'm going to have negative 1 comma 2 is my center. Under the x term, I see nothing, so there's an invisible 1. So I go plus 1 and minus 1 from the center. Then under the y, I see a 2. So I'm going to go plus or minus root 2 in the y direction, which is about 1.4. So here is square root of 2. Now I can make my box and draw my diagonals. So there are my asymptotes. And the slope of this asymptote is up root 2 over 1. So square root of 2. So the equation of the asymptotes, I'm going to write it in point slope form. So I have y minus 2 equals plus or minus square root of 2 times x plus 1. So those are the equations of my two asymptotes. Then the x term is first in the equation. So that means I open right, left, and the blue dots are the vertices. So let's write what those are. Vertices are the blue dots, 0, 2, and negative 2, 2. We could say what the transverse axis is at this point. It's going to be y equals 2. And we can draw our graph since we know it opens right, left, and we see where the vertices are. You could label them if you like. Okay, so I've got, looking for the instruction set. I've got the center, the transverse axis, the vertices, and the asymptotes. So I need the foci. So little c squared is the sum of the denominators. So it's 3. And c equals plus or minus square root of 3. So the distance from the center to the focus, here's the focus, that distance is the square root of 3. So that means the foci, the x-coordinate starts at -1, and then it's plus or minus the square root of 3, and the y-coordinate of 2 doesn't change. Okay, so the last thing I want to do is an application problem. And we have an obstacle course with a concrete tunnel shaped like an hourglass. And the sides form a hyperbola with the smallest diameter, 5 feet, occurring in the center of the tunnel. So they're telling you there's some symmetry happening. The tunnel is 20 feet long. And the diameter of each opening is 10 feet. Okay, and we get to decide where to put the origin. So let's put the origin at the center. And so do you see that if you put the origin at the center, the coordinates of this point are 0, 2.5. So you go none right or left and then up half of that distance because of the symmetry. So 2.5. And then if I go to the right 10 and up 5, I'll be at this point, the highest point. And that point has coordinates 10, 5. So make sure those coordinates of those points make sense to you. So we know that this is an opens up down hyperbola, and we centered it at the origin. So opens up down, that means the y squared comes first. And then I don't know about the x direction yet, but I can see in the y direction I go up and down 2.5. So I need to figure out this denominator under the x squared term. But I haven't yet used this piece of information that the point 10, 5 is on this hyperbola. So the point being on the hyperbola means it has to make the equation true. So when y is 5 and x is 10, this equation has to be true. So that's going to make it so we can solve for the b squared. So I would multiply both sides by 2.5 squared b squared so that I wouldn't have any denominators to deal with. Then I'm going to distribute. And that will give me with 25b squared as my first term minus 2.5 squared times, I know 10 squared is 100. And that's going to equal 2.5 squared b squared. Okay, so now I want to gather everything that has a b in it on one side and everything that doesn't have a b in it on the other side. Let's go ahead and calculate. The 2.5 squared is 6.25. So let me just write this as 25b squared minus 625 equals 6.25b squared. So I would add 625 to both sides and subtract 6.25b squared. So that's going to leave me with 18.75b squared equals 625. And then I'll divide both sides by the 18.75. And I'm getting about 33.33 repeating. So don't round that off yet. Let's call it 100/3 since it's 100/3 exactly. So let's use 100/3. So let's write our equation of our hyperbola now. We have y squared over 2.5 squared minus x squared over 100/3 equals 1. And then the question that we're being asked is, to find the equation, round values to the nearest hundredth. So I guess we would write under the x squared term 33.33. So this is the equation that models that hyperbola. And then you could be asked other questions like, how wide is it at 2 feet away from the center or 3 feet away from one end? And you would use this equation to model that. So let me know if you have any questions.